Great. Well, first of all, thanks so much everyone for coming to Space Aeronautics Preliminary Design Review and MV-1. All right, before we get started, here's a quick agenda. First, we're going to start with team introductions. We have a lot of new faces. Your supplements are mostly random this year. Then we're going to go over our competition, design, build, and fly, as well as our previous entries. Next, we're going to go into details this year's competition, mission requirements, the specific challenge, scoring criteria, tech inspection, as well as sensitivity analysis. Next, we're going to go over our competition aircraft, MV-1, its overview and layout, as well as our schedule and budget. After that, our subcommittees will explain their part and give progress updates on their ends. We will be starting with aerodynamics, structures, avionics, and banners. So for team instructions. First, myself. My name is Emir. I'm the project manager of Space Aeronautics. I am senior mechanical engineering major.
I'm Gil Rivas. I'm also a senior mechanical engineering major. I am the systems engineer.
Hello, my name is Francesco Biteto. I am a sophomore in mechanical engineering, and I am the chief engineer.
In our aerodynamics team, we have Rahul. In structures, we have Shane and Nathaniel. In avionics, we have Nathan and Jake. Here's our team structure. There will be 400 AIAA wage. We are one of the two competitive project teams of rocketry. This year, we have 3 sub-teams. Those are aerodynamics, avionics, and structures. Our payload sub-team is called banner system this year, and it is the mechanical engineering capstone team, which we'll get to that in a bit. We have 14 members, 7 of which comes from structures, 3 from avionics, and 4 in aerodynamics. And this year, our faculty advisor is Dr. Baxilanis.
All right. So I'm going to give you a quick intro about the AIAA DBF competition. And so the AIAA competition, or Design Build Fly competition, is a competition held by AIAA every year. It has unique challenges each year, as well as a unique theme each year. Every year, some of the commonalities, though, is there's always 3 flight missions and 1 ground mission. And there's always a top 300 proposals on about the fly. This year, the fly-off will be taking place in Wichita, Kansas, in April. So our previous entries in the competition is the Flying Cougar. This competed in 2023. However, this did not fly competition due to some logistics and manufacturing issues. We did, however, have 5 successful test flights. For 2024, we entered with the Carbon Cougar. This was actually the first time the team ever attended competition. So it's a great milestone for us. We even passed tech inspection, which is also, I'll get more into what tech inspection is in a bit. That was a huge milestone for the team as well. This plane also completed 2 test flights prior to competition. However, at competition during mission, our attempt for mission 1, our plane did stall out and crash. So that was the end of our time at that competition. As for this coming year, the main theme is to design a banner towing bush plane. And so there are some major constraints in regards to this, which is we have to have a wingspan between 3 to 5 feet, a max battery capacity of 100 watt hours, a max takeoff gross weight of 5 pounds, and each mission has to be done within 5 minutes. And I'll get into what the missions are in the next one. So for mission 1, the goal is to complete 3 laps within the flight window and complete successful landing. This is the flight course that you see there. That one full trip around that is 1 lap. And the score we get for the complete this mission is just 1. So it's basically a completion score. For mission 2, we do have a passenger and cargo that we have to carry. The passengers being a toy ducks, and the cargo is hockey pucks. And so the main constraints for this mission are we have to carry a minimum of 3 passengers and 1 cargo, and we have to have a minimum cargo to passenger ratio of 1 to 3. However, we can have more passengers than cargo. And we also have to be able to load our payload in 5 minutes. The score for this is 1 plus net income, with net income being based off of the number of ducks, laps, hockey pucks that we carry, as well as our efficiency factor, which is based off of our propulsion battery. And our net income is added based off a ratio between our net income and the top scoring team for net income at the competition. For mission 3, we actually will have to successfully deploy a banner after takeoff and complete as many laps as possible. We also have to successfully release the banner after we complete our laps and before landing. Some of the major constraints for this is the banner has to be at minimum 10 inches long and 2 inches tall. There's also a max banner length height ratio that is 5:1. However, we can have a smaller ratio if we want. And the banner has to stay vertical during flight and must not contact the ground on takeoff and may not tear, rip, or fray during the entire flight. And it must successfully deploy and release during the flight. As well as there's also a requirement on the banner having a logo, university's name, and our team's name on both sides of the banner. For this, the scoring for this mission is 2 plus a ratio of basically the number of laps to complete, the banner length, and our RAC score. RAC score is based off of the wingspan. So it's basically 0.05 times the wingspan plus 0.75. And again, our score is dependent also on the max scoring team for this category aircraft. For ground mission, we have to complete the following as fast as possible, which is we have to load and unload our passengers and cargo, install the banner, verify that flight control systems are active, and verify deployment and release of the banner. For this, the major constraint for this is just there's a 10 by 10 feet staging box that we have to complete ground mission in. And our score for this is just the minimum time any team at competition made, the maximum minimum time that any top scoring team got for this mission over our mission time.
Right. So we conducted sensitivity analysis to identify characters with greatest influence on each mission. How we did it is we started with the backup aircraft performance code. We first created a baseline parameter, and we took each parameter that affects the mission individually and increased it and decreased it by 30% while keeping all other parameters constant, and calculated the resulting changes to mission outcomes. Those are calculated and then plotted on the graphs as below. Here, higher slope refers to the more sensitive mission parameter, and positive slope refers to the positive correlation. That is, as you increase that value, your mission score also will increase, and negative slope refers to the negative correlation, meaning as that value, your score will decrease. In mission 2, we see cargo number, passenger number, and lap number all show constant correlation with number of cargo being the most sensitive parameter to the outcome, even though it adds extra weight to the aircraft. We see efficiency factor showing the correlation, and again, efficiency factor is just our battery capacity in watt hours, even though keeping the efficiency factor low means you'll have, it means the plane's gonna have fewer achievable laps. When we look at mission 3, the data is more interesting. We see lap number as most sensitive parameter, meaning it's better to increase our lap numbers. The banner length is not entirely a linear function, and that is because as we increase banner length at a certain point, the drag forces on the aircraft will be high, meaning it will slow down plane and it will cause fewer lap numbers. The RAC shows negative correlation first. That means having a lower wingspan is more beneficial. And in fact, as you can see here, the code suggests a lower wingspan than the baseline parameter. But this was justified with flying faster to compensate for the lift loss. but this approach wasn't preferred as flying faster increases in drag forces on the aircraft, which resulted in lower achievable laps.
Now, due to all of these constraints that are shown to us by the missions and our sensitivity analysis, we took several different approaches on each mission when it came to the design of our aircraft. For the first mission, it was very simple. We just wanted to ensure that the aircraft had enough maneuverability and good enough velocity that it could complete all 3 laps under the 5-minute window. For mission 2, we needed to prioritize the amount of cargo and ducts we could load in it. We needed to have as many laps as possible. We needed to ensure that our wings were strong enough and provide sufficient enough lift so it could lift that extra amount of weight. And we needed to make sure that the cargo could be loaded quickly enough under the 5-minute window. For the third mission, we had to prioritize our stability of our aircraft to make sure that the banner stays in a vertical position. We needed to balance our speed and efficiency, and we had to minimize our wingspan. The mission 3 and 2 do kind of contradict each other because to have more lift, we require a bigger wing, but we also want a smaller wing. So we ended up somewhere in the middle. For our ground mission, we are ensuring that our payload hatches and all of our loading systems have easy access to them, so we can quickly load them in the quickest way possible. We're also making sure that the banner loading system is simple enough that it will not be a hassle and take extra time.
So give a little more feedback or more background on what tech inspection is. Tech inspection is something, a set of requirements that we have to pass before we can attempt any mission tech competition. So we have to take into account our design decisions. Some of the main criteria for tech inspection, we have to have a signed pre-tech and first flight certification form filled out before we make it to tech inspection. We also have to have a video showing straight and level flight of the aircraft prior to competition. All arming fuses must be at least 6 inches from the propeller, and our main battery has to be under 100 watt-hours. We also have to verify that all our 3 banners must be submitted at tech inspection and fast tech inspection, and as no extra banners may be approved after that. We also have to verify that fail-safe mode, which is if the aircraft loses signal from the controller, it will automatically go into fail-safe mode, which is throttle close, pull up elevator, pull right rudder, pull up aileron, and all full flaps down. And this is just basically a safety requirement.
As of previous years, we weren't so successful. Our goals for this year are very simple. We want to be able to attend fly-off, have a fully working prototype by late January, and our plane is going to be able to fly all 3 missions and complete our ground mission. Now we're going to get into the building and the layout of the MV-1 plane, also known as max velocity 1. So we're going to be doing a monoplane with a high wing and conventional empennage. To maximize our cargo space, we have chosen to go with an integrated fuselage. For simplicity of circuitry, we are going with the single tractor. To ensure the space of the banner is enough, we have chosen a tricycle landing gears configuration. Our wingspan is going to be 51 inches with a core length of 15 inches. And to ensure that our center of gravity does not shift in the extremes between each mission, we have chosen to do a dual decker payload. Our major milestones for this plane is going to be right after this. We're going to start implementing all the feedback we get from this event, and then start manufacturing the prototype 1 all the way up to late January, then we will have our critical design report and start the design of the final aircraft. By March, we will manufacture the final aircraft and complete all tests, including a bunch of flight tests, making sure that all our missions are done, are capable on stable flights, and have the reporting for tech inspection. And on April of 2026, the competition will be held at Wichita, Kansas. This is our current Gantt chart. As you can see, we are currently on schedule, and we are headed towards manufacturing our prototype. This is our team's current budget. We have a projected cost of around $6,000. They're being sponsored primarily by Ford, who are giving us a lot of help with the components and the structural designs, but we still do need more funding. So, especially on our logistical side, this budget currently reflects us taking 10 people towards competition. We would like to be able to take more, but right now we are requiring, we just 10 people, we will require an additional $4,200. And now we're gonna talk about our aerodynamics team, and Raul will present.
Hello everyone, I am the Aeronautics SPL. I will be from the Aeronautics here. A little bit of view of what the aerodynamic trucking does. We design, manufacture, lifting services and control services of plane. For lifting services, the empennage, the control services or the ailerons, rudder, elevators, you name it. And then to do so, we perform aerodynamic and stability analyses using experimental and computational methods to ensure that the aircraft have functioning lifting and control services. So there's really two components to these. There's the analytical components and structural components. The analytical components include the airfoil selection, the wing and tail configuration, the lift analysis, and the stability analysis. After which we implement those results to really design the wings, empennage, and control surfaces, which is really the more structural aspect of it, which we collaborate with the structures. The softwares we use are XFLR 5, COMSOL, MATLAB, and VersaCAD. The wing airfoil selection. To do so, we used a custom MATLAB script, which was developed to automate CFD, particularly 2D CFD simulations in COMSOL. 19 airfoils were analyzed, mainly chosen from previous competitions and research. The simulations were done at the estimated cruise speed, about 44 miles per hour, and also took into account the selected tour length was 15 inches and the accurately matched Reynolds numbers. So out of the airfoils that we analyzed, 4 really stood out to us: E393, NACA 5512, SD7032, and FX63 137. Ultimately, we did choose SD7032, mainly based off of its lift performance as well as its manufacturability. We had a close call between SD7032 and E393, mainly due to both of them performing fairly well, either in the lift curve slope criteria or the aerodynamic stability. Ultimately, SD7032 won out, mainly due to its higher manufacturability due to manufacturing constraints. And that was particularly because E393 had a particular camber, a very particular camber that if we did not manufacture correctly, it would have been a completely different aircraft. So a little bit into these particular airfoils lift to angle of attack. So what does this graph describe? It's how much lift the airfoil would produce relative to the surface area at the angle of attacking. You want it to you want stable increase in relation to the angle of attack, and it's expected that it stagnates near the stall angle, which is around 15. So the aerodynamic efficiency of said airfoil, it really describes how the lift and drag increase in relation to each other. As we can see, the increase as drag increases, we expect the drag should stagnate, as the lift increases. So a little bit into the pitch moment. This describes the airfoil's tendency to pitch up or down based on its camber. The ideal pitch moment of an airfoil is around 0. As we can see, the increments for the pitch moment really don't increase much past 0, which is ideal, meaning that the airfoil itself would be stable during the boost. So a little bit into the stall angle itself. So XFLR5, the open source software we use commonly for aerodynamic analyses, gave us 17.2 degrees. However, the console analyses gave us 16 degrees. So the stall angle is the angle at which the wing loses its ability to produce lift. And based on the results, we assumed a 1 degree margin of error. Given the margin of error, the real operational stall would be 15 degrees so that we don't risk stalling off at the cruise condition. And if you see here, this is an XFLR simulation showing you the stall angle and lift produced. And it would eventually start sloping down because the wing would reach the stall. So moving on to the empennage airfoil, we chose NACA 0012. All the listed airfoils, NACA 0009, NACA 0010, they all perform fairly similarly. Ultimately, we did choose NACA 0012 mainly because it's easier to manufacture, primarily due to it having a greater thickness. So the empennage airfoil's aerodynamic efficiency. What this is the coefficient of drag in this context is steadily increases as the lift rapidly increases. What this ensures is controllability at the different flight phases. So takeoff, cruise, and moving on to its pitch moment, it's fairly similar to the pitch moment, what we want in the pitch moment of the wing. This is extra important when it comes to the empennage because mainly due to its associated control surface, particularly the elevator, which allows us pitch authority. Therefore, the airfoil needs a strong, stable, natural pitch. So the wing configuration is high wing. This is due to mainly the aerodynamic efficiency as well as the controllability. Commonly, most common wing configuration of a bush planes in general is usually see high wing. We also considered mid wing. However, high wing ultimately won out mainly due to the structures team's concerns with height. The wing shape we chose would be rectangular. And this is because mainly due to manufacturing as well as the trade study shows it performed well across both boards, aerodynamic efficiency, stall, and the lift curves. The wing shape's aerodynamic efficiency, this shows the wing efficiency versus the angle of attack. And we expect a drop off in the efficiency as the angle of attack increases. Favorable behavior would be around the efficiency at 10. Okay, favorable behavior is the efficiency staying above 10, even as angle of attack increases, which this graph clearly demonstrates. So what is stall in relation to the wing shape? So it's particularly the stall distribution, and it's how the stall progresses along the wing as lift increases or decreases. So as we can see, we have sort of this octagonal trapezoid shape going on. This was ideal due to how the stall would interact during takeoff. So the wing sizing we had is a 15-inch board with a 4.25 feet wingspan. This was mainly chosen to maximize the RAC benefit while optimizing lift characteristics. How we designed the wing, it's a rib and longeron design. That will be covered in more detail by structures, and the mounting angle of attack is 3 degrees. So the empennage configuration, we chose conventional. Across the board, it really did perform better than the other listed configurations. H-tail was also heavily favored. However, we ultimately chose a conventional tail, mainly due to experience in manufacturing. So the empennage sizing, we have a uniform 8-inch cord for both horizontal and vertical stabilizers. A uniform cord just means that the cord spans the same from the tip, and the span of the horizontal stabilizer is 24 inches, while the vertical stabilizer is 12 inches. What this would ensure is that it's stable handling at the cruise condition, which is 44 miles per hour. And this would minimize drag while not sacrificing the controllability. So the control surface sizings, so we have an aileron sizing of 5 inches at and on about a foot of span. The elevator sizing is 3.5 inches of the cord, and it's 80% of half the span of the horizontal stabilizers. So that's about 0.85 feet, and the rudder is 90% of the span, so about 11 inches. It's 10.8 inches to be exact. However, due to ease of manufacturing, we could also do 11 inches. And this is a timeline of specifically the aerodynamics sub-team. Currently, we're finishing up mission-specific analyses. We're also going to look into critical analyses, which basically means taking into account the weather conditions at Kansas, which would depend on weather data that we would have to research. And then the winglet trade study is also in progress, and we are also doing ANSYS. We're also doing CFD on a software called ANSYS to help guide the preliminary CAD design, which is also currently in progress in collaboration with structures. After which we really integrate a lot into a sort of aero structures setting. The structures team is about the same timeline as they would have, and then final prototyping as well as documentation. So there are really 2 tests that the aerodynamics team would really be involved in. That is the wing loading test and the CG test. Mainly we're involved basically to validate our analysis data, specifically the lift distribution, the center of pressure, and the load path assumptions. So next is the structures.
Hello, I'm Nathaniel.
I'm Shane.
I work both the structures lead.
So for an overview of our team, this year we will be creating 2 aircraft, a prototype and a final aircraft. As the structures team, we are responsible for designing, testing, and manufacturing structural components for the first aircraft, doing the same with the second using our lessons learned first. We will be responsible for helping aerodynamics and various other sub-teams with their fuselage, wings, empennage, payload integration, and landing gear.
So our goals for structure is to make 2 aircraft. The first aircraft is going to be our test aircraft. We're going to put it through rigorous testing for us to better make our designs better and refine them for our final aircraft and vehicle.
For our fuselage body, we are using an integrated fuselage design, foregoing the carbon fiber tail boom that we've used in previous entries. However, we are still going with previous entries use of laser cut wooden components, creating a jigsaw design of frame ribs and bulkhead. This will be made either with a laser cutter with either a basswood or also with 3mm sheet construction. All of this will be covered in a monocot style skin. We really chose the integrated tail boom due to the just much larger internal volume and the adaptability of what we can do with that internal volume, especially with this year's team missions.
So our fuselage is going to be a 2-deck layout fuselage, where the top deck will have the cargo and passengers, and the lower deck have the avionics and the banner deployment system. Having the two decks helps us better organize the internal components and allows us to have the heavier components like the pucks and the avionics bay to be in the front of the plane to help us with our CG.
For our wing structure, we're going to be using a very similar construction style to our fuselage. They're going to be laser cut wooden components. They're going to contain longerons and ribs. They're going to be in total 3 carbon fiber pieces constituting 2 systems. There's going to be 2 20mm square tube spars as our main wing spars, and 1 1/4 inch carbon fiber rod reinforcement piece, and that will be used to counteract torsion near the wing tips. These are all going to again be covered in a monocoque style skin, and as aerodynamics team mentioned earlier, going to be utilizing the SD7032 airfoil.
Our empennage is going to be a conventional airplane, a conventional style. We're going to have 2 elevators and 1 rudder. It's going to have the same construction as the wings. It's going to be made out of laser cut wood and wrapped in monocoque. And the airfoil is going to be the NPC, the NACA 0012, based off of the aerodynamics team's announcement.
For control services this year, we have yet to consider, or not yet consider, we have yet to finalize a main decision. We have 3 main options that we have considered so far: styrofoam, 3D printing, wood. Are the teams trending this year towards using a 3D printing construction, especially on the ailerons, elevators, and rudders?
So there's 2 types of payloads, the ducts and the pucks. So through our calculation analysis, we went through different combinations, and we decided on 14 passengers and 4 pucks, 14 ducts and 4 pucks. This is due because of the space the passengers take up, and we cannot stack them. And with this, we are integrating this into our fuselage to make sure there's ease of accessibility, and so we can actually access them from the outside.
For our banner deployment system bay, we're working closely with the capstone team to create space on the aircraft for our banner deployment system. It'll be located on the lower deck and it will partially hang out the bottom. The integration is more than just an open space. There's also a requirement of finding mounting locations that work with the capstone team. And so that does mean that collaboration is required with banner systems and avionics, along with aerodynamics for the drag.
So for landing gear, we looked over 3 different landing gear configurations, and because of the banner system, where the banner cannot touch the ground during takeoff, because it's going to be located under the plane, we decided to go with a tricycle design, which has a single nose gear in front and 2 rear gears, wheels in the back. This gives us a larger ground clearance during takeoff, and our front landing gear, we're gonna construct it this year, and we're gonna also with machines.
For our timeline this year, we are, of course, in the 3rd week of November. By the end of November, we should have finished up our CAD design for our first prototype. And then up until late December and early January, we will have been working on, designed, and created our prototype 1. After doing testing on prototype 1 with the assistance of the various other teams, we'll then start the CAD design and finish our CAD design of our final prototype by mid-February up until CDR. Our manufacturing will then go past CDR, which is not shown in the timeline. Our design report will be taking place across the entirety of our assembly process in order to properly document our decisions and why we need.
So our testing is very similar to the aerodynamics team testing, but we're more looking into the structure of wings. So on wing load test, we'll fix one end of the wing to a fixed surface, and we'll put weights on the other end to see how much force our wing can withstand. And then we're also going to do CG tests to figure out where our CG is.
For our budget this year, we have a large excess of unused materials. This is due in part from purchase order meant for last year. So as you can see in the image, we have quite literally a carload of materials used. This includes a large amount of carbon fiber spars and rods, and a large amount, about 50 sheets of each of basswood and balsa. Beyond the structures, materials that we already have, our landing gear, filament, and monocot wrap miscellaneous will end up costing us about $425 from the materials we already have. And I will let avionics go.
My name is Jake. I'm one of the honors complete. So the main requirements of the avionics team this year is to provide power, control surfaces, and propulsion for the plane. We also find the most optimal motor and propeller combination that will provide the most amount of thrust, multiple amount of thrust possible as efficiently as possible. We also ensure that the control surfaces or the control servos have enough torque to be able to control have enough load. They have the servos can control the loads that being put on them and also ensure that the plane is ready to effect.
Now, this is avionics circuit diagram for this year. In the top left, we have our battery, which goes through a 100 amp fuse and powers our electronic speed controller. The electronic speed controller then gets signal from the receiver, and the electronic speed controller translate that into how much the motor should spin, so that be fast or slow. The receiver also controls 8 servos. 5 of those are control surface servos. 2 of them are banner servos, and 1 of them is a landing gear servo. The receiver itself is powered by a universal battery illuminator circuit and a small 2S lightning battery, which is called switch.
So the motor we chose is the Sky XP20. The reason we ended up choosing this motor is due to its high thrust capabilities, efficiency, and reasonable cost. It has a recommended battery of a battery, and the efficiency is about 3.89 grams per watt at maximum thrust. And we are deciding on a propeller of 20 by 8 inches. We're going to exactly how we'll determine what exact propeller we'll use. This is controlled by an electronic speed controller by Spectrum. It has a max amperage of about 100 amps. It has a recommended battery of 3S to 6S. The battery connector is a proprietary EC5 connector, but we do have the capabilities of making our own battery connectors. So if we need to go from that standard to another standard, we have done that in the past, and we already have some in stock. And we also have it's a smart ESD meaning that we can program it to have different amount of thrust or whatever for the capabilities.
Okay, this is our battery for our circuit this year. It is a Mercury 6S 4500 milliamp hour LiPo battery. Competition rules state 2 things. One, that maximum capacity for battery is 100 watt hours, and the second being that if your battery is as your battery approaches 100 watt hours, you lose certain points. But our battery is 99.9 watt hours below the 100 watt hour limit, and also analysis will determine that even though we lose some points because of our battery capacity, it makes up for it because we can go more laps and have more.
So the transmitter and receiver that we chose this year is a Spectrum 8-channel transmitter and receiver. The frequency for these transmitter and receiver is 2.4 gigahertz. This is a requirement on the rules, so this satisfies that requirement. The 8-channel satisfies all of our servo needs. We need 5 control surfaces, 2 for the banner, and then 1 for the landing gear. So that satisfies that requirement. The receiver also has the failsafe mode. We can program it on the transmitter to the receiver, so we can program it to the requirements needed. It's also powered by a separate 2S battery and also has an external straight as well.
This is the servo motor that we're going to be using. This is Aero. That's actually what the manufacturer named it. It has 100 degrees of rotation. It weighs 40 grams. It has 4.68 kilograms per centimeter of torque. It can do its entire rotation in less than half a second, and it is only $10.
We, as Aeronautics, identified 4 different testing priorities that we need to be looking at. The first one is full circuit testing. This is basically we put the full circuit together, motor, ESC, servos, everything, without the propeller. Just making sure does the motor spin up, the servos control move on their own with the input of the transmitter, and is everything receiving signal properly. The next thing is the motor propeller testing. This is basically us putting the motor and trying different propellers to figure out what gives us the most efficient, the most efficiency at a certain thrust. So we have a certain cruise speed that we want, but we want to figure out what is the propeller that can meet that needs and have as efficiently as possible. Because we want as much battery life as possible, so we have a longer lifetime. After that is thrust testing. We do get numbers from the manufacturers, but we want to verify those thrusts, especially with our certain propeller. So it's just us spinning it at full speed and figuring out what the maximum amount of thrust is for that motor and propeller combination. And then we do battery drain testing to make sure we know exactly how long we can fly on charge of our battery. This is our avionics timeline. Most of what we have done already is just doing trade studies and making sure we know exactly what equipment we need and if we already have it. And so now we're going to the phase of actually assembling the circuit and actually creating the motor prop test stand. This will go all the way up to the second week of December. After that, then we can go into full circuit testing in the beginning of January, which will lead into thrust testing and battery testing going into the second quarter.
This is the avionics budget for this year. The cost of our avionics materials is $1,016. However, same for a couple of the servo motors, our propeller, some wiring, and some maintenance stuff. The actual out-of-pocket cost from $150 because we have most of our.
That's his banners.
Right, so I mentioned that January 16th something is capital team. It is in fact my capital team, along with Matt here, Sean, and Daniel. So the scope of our capital team is basically everything that we want Mission 3. The project can be broken down into 2 parts. One being the reliable and remote deployment and release of the banner, and other being the banner material selection and the dimension optimization. Our goals, obviously, maximizing change restore through reliable deployment and release mechanism. The goal is to limit the banner jack forces below 10 newtons, which was determined based on our calculations using the aircraft performance code. And we also keep the banner length greater than 25 inches.
So one of the challenges that we face in our kind of systems design is that since we have to design the shipping large banner, we have to ensure that the drag stays 14 pretty tough to determine what drag would be for small sizes of things. So in order to this, we created our preliminary prototypes. And you can see here from the top down, you can see denim into different sizes. And so these prototypes in order to help us determine the relationship between material selection and banner size. Correct. Here's the force gauge inside of the wind tunnel, and we mounted each of the banners to it. Something we picked out in the bottom corner. So we mounted the banners and we set the wind tunnel to the known flight speed that we decided on. And the force balance after the test run gave us the value, which we interpreted as our hypothetical the maximum drag value.
with, our hypothetical worst case scenario. So this experiment just basically helped us to determine, just how, material selection and banner size will affect flight behavior.
All right, so these are the results from our initial experiment. You'll notice that the drag coefficient varies the most based off of what material it is. Look at Venom as an example of really bad 3D. It also varies though by the size of the banner as well as the speed of the banner, if it's the same banner size, same banner material. This makes sense though, as we're working with very low Reynolds numbers, so the drag coefficient is just going to vary wildly. What this does provide us though is a rough estimate of what our drag coefficient might look like for our real banner. Using those results, we're able to actually analyze different banner sizes at different speeds. We set the banner length, banner height, and the lap count as our inputs, as these are all the factors that directly contribute towards our score. This then lets us determine what the optimal size and speed of the or the optimal size of the banner and the speed of the plane is for mission 3, while making sure that we keep that drag under 10 newtons and we keep the velocity within the flight range that the plane is able to be. We set the drag coefficient as 0.0215. This is higher than any value that we got for the good materials in the experimental data, and that's to account for both going at faster speed as well as a larger size banner. Through this analysis, we determined that our next prototypes are going to be a 19-inch by 18-inch banner, which we're going to be flying at roughly 19 seconds.
So we conducted a trade study over 5 females. Based off polyester and like 3 preliminary prototype materials, which are again like polyester, screen. So the criteria we used to judge these materials was fabric weight, durability of fabric, how stable banner would be during flight, size sublimation durability, and cost and visibility. You can see here that our top choice was Ripstop nylon. Ripstop polyester in the second place because it was a bit heavier than Ripstop nylon. We still have to do physical testing on prototypes made on nylon and polyester. Excuse me, Ripstop nylon, Ripstop polyester. So we are confident that Ripstop nylon will remain our top choice.
All right, for the actual banner deployment mechanism, we chose this rotating hooks design. It features a long rotating arm with 2 hooks on it. These hooks will be facing upwards initially while the banner is being stowed, and 2 straps will be attached to these hooks. When the servo is activated, the lever arm will rotate 180 degrees, changing the hooks from facing upwards to downwards, dropping both of the straps that are keeping the banner in place, and then deploying it. It'll just naturally fall due to gravity and unfurl. For the banner release mechanism, we chose what we call the linear actuation design. It features a pinion gear, where when the servo activates, the entire rack will move across it, releasing a small hoop. This hoop will have the tow lines directly attached to it. So when the servo is activated, the rack will move off, dropping the hook and dropping the tow line as well as the whole banner. As far as the banner system's timeline, we have just completed our preliminary design. We're still working on finalizing the dimensions of each of these mechanisms. Our next big steps are going to be purchasing an order list to test a full prototype of all of our systems, as well as testing those next 2 banners with the new materials that we got, just to make sure that our initial banner analysis. As far as our budget, our total price came up to a little over $200, but factoring in resources that we already have on hand from previous years, the cost comes to a little under $90.
All right. So this concludes the update of the sub-teams. Final note, event MV-1 National One is our 3rd point-zero team DBF 2026 competition. And we will be hosting critical design reviews during Okay, so the main thing, most of you guys are ready for it. Some of you guys already know, some of you may not know. But we submitted our proposal last month, and the results came in 2 days ago. And I am incredibly happy to announce that we placed 17 out of 175 teams, which is the greatest ranking in our history. In points wise, we scored 80 points. And considering the first team got 86 points, in that sense, we're actually 7th place, which also means that we placed top in Texas. Fourth place in Texas, while we cheered first place schools, Middle, MIT, Chidong, and all other Texas schools. With that being said, I would like to thank you to, first of all, my supplement leads, all the members. This is all possible because of you guys. Other people, I'm going to get names real quick. Maddie, our team mentor, Andrew, Isabella, Emma, going from that of the executive board, Steph and Brad, our alumni advisors, Tommy, Andre, thank you so much for being here, and Jalista. And from our main faculty, Dr. Huang, Dr. Chang, Dr. Honest, and big thanks to you for sponsoring this project. And with that being said, we are concluding the presentation and we would like to take questions. Thanks so much.
Well, it's okay,
Questions? Further down the line, there is the document, fill that out.
Yes.
All right.
Yeah.
I'll go last. Okay. I feel like we could ping pong. I have a lot of questions, so.
Not bad, don't worry.
Some of them are bad. It's okay. They're not really. A lot of these questions I had during the presentation were answered throughout the presentation, I will say. I think you should have mentioned the capstone team, specifically who the members of the capstone team were as you introduced the team. Like, I know you introduced the sub-team leads and such, but I think for a components as important to the scoring as the banner is, it would be good just to name the contributors and who they are, especially because y'all are very involved with the team. That was a concern that I had, was how separate is the capstone team from the actual team, right?
Speaking of, because some teams will do capstone for their project and it ends badly because they're kind of divorced from the overall team. But since once you got to the capstone portion, we saw who was in the capstone. You guys are very integral to the team itself. So I was like, okay, we know you guys are going to make sure you're staying on track. So good on that. And good that, the people that are going to be really keeping the team on track are also the ones on capstone. If ever doing future capstone stuff, probably best to keep it that way. That way it's not, that way the team doesn't get a way to just kind of do their capstone separate from the competition. You want to make sure that's really together, which it is. So
I did write for the caps when y'all talked about the banner. I did write very good presentation, probably very good because you had to do it for capstone.
Lots of presentations for capstone. That's for sure.
But Raul, so how in depth was the angle of attack stability analysis of the different airfoils?
So I was mainly focused on the XFR5 aspect, right? I did an LLT analysis and also stability analysis as well as side slim analysis.
Okay.
And then Amir and I believe some of the capstone members, they were more involved with the ComSol aspect.
I noticed, and a lot of y'all made the same mistake, which is not really a mistake when you're dealing with the timeline that you have to work with, and also you are a student team, is that a lot of the trade studies were more holistic than they needed to be. like, I assumed because I saw a lot of like 7, 8, 9s, you were like using a ranking system of like from 1 to 10 to score a lot of criteria that was numerical, right? Like you put a 9 for drag or something when you could have put the actual number that you got from console. And I saw that repeatedly throughout the trade studies to where there was a value that you could have put to have an objective choice that was not put. Not saying you made a bad decision and not saying that you should reconsider it, because I think you all made the decisions that made sense. But I just believe that in terms of credibility and in terms of the actual engineering, you want something that's based in reality, based in the data gathered and based, on data, which the capstone team did. I will say that y'all did very good with that. I love the whole system where you determine the banner length from like first principles and experimental data. So that
You have a
was
chance to
very
do this for the design report and the CDR. Most importantly, the big one is the AIAA design report. And it's like, it has to be submitted. You can definitely do that for that. So
Oh, yeah.
whenever you go back and do the trade studies, you can fill that in with the actual data for the design report, which is where it's really gonna matter.
And I think it's data you already have as well,
Yeah.
which is why I feel like it was a missed opportunity. You could ask a question.
Oh, I'm waiting. I've got.
Well, you can ask like 1 or 2.
I'll-
I've been
I'm still gotta
real
figure out
quiet
what
in
I want to
there.
ask first.
I probably should have opened.
Yes.
Very good presentation. You are all doing amazing.
Does anybody else have questions? Just want to make sure that we don't hog much because we got really long papers.
Yeah.
In terms of testing for aerodynamics and structures, it didn't seem like there was much.
I also had a big issue with that, by the way.
Like, is there wind tunnel testing not gonna happen to confirm your CG values? What's the plan for the future?
So currently our plane size thing with the wind tunnel we have available on campus, the plane would be too big. We are talking with another capsule team about making a test stand. Progress on that, it's up in the air right now, but that will be testing that happens on next semester, during next semester.
So, one, also time, make sure as soon as possible. You guys can make a scale model as well.
So I can add into that. We did look at Reynolds numbers, in order to match them. The scale model has to be as big as possible.
Yeah.
In the wind tunnel, and we had to turn on the wind tunnel as fast as possible. And that was barely matching Reynolds.
If you can get it pretty close,
Yes.
that'd be good.
But the capsule team is actually breaking up in a mount that will go to the car, which will mount, gimbal mounts are clean.
Been
And
dreaming
that
of
way-
doing that for a while.
Yeah, it's Tommy's car.
It's, oh yeah, because
Yeah,
oh,
yeah.
okay. I'm gonna be talking to Tommy.
Yeah.
He'll probably call me at some point to say.
I'm
Yes, he does have the whole camera rig set up. That'd also be good for the propeller testing, which this is something that I did have to go off of. Definitely test that with the whole plane, but also with the motor, because you can do the testing stand for the motor and you can get all the data for that, but you're also gonna maybe get different data when it's at speed with wind going against the propeller. So when the propeller is pushing against just stable air, it's a little different than when it's actually traveling at the speed. It might be the same, I'm not sure, but I know probably some people with more experience will be able to say for sure, oh, it'll be the same, or no, it's gonna be different, but you should definitely test that regardless. So with Tommy's car, the test stand for the motor should be pretty good. We just to ramp up the motor, test the efficiency, test the battery and everything at speed. So yeah.
to add more to the testing for something. In something sites, you only saw something specific testing. But we will also be doing on full field tests, such as first of all, mock mission test for each mission, ground mission test. We also test the tech inspection. Not sure.
Yeah, we will be conducting mock tech inspections and hopefully get some third party, hopefully one of our alumni to come in and read tech inspection and then view our plane and see if it would pass or not. We also do plan to conduct actual flight tests with our prototype. So before we even begin construction of prototype 2, we plan to take prototype 1 and actually test fly it and get results, and using those results, incorporate that into our design.
As with previous years, of course.
Yes.
As soon as you can get a prototype done.
Oh, yeah, we're
Yes.
already on the process of getting
Yeah.
everything ready for inspection.
Because you guys will also need some flight experience, like plans for flying the course, because at this point, we've yet to actually fly the course itself. And so making sure that the pilot can fly the course, making sure that the plane can do the maneuvers for the course. Sometimes planes just don't take turns very nicely, especially that 360 loop. Just want to make sure that it stays stable in that loop, especially when maximizing the RAC, which minimizes wingspan. Just when you get a really short, stubbier plane, likes to roll over. Sometimes that's an issue, sometimes it's not. So just flight experience as best you can.
No,
Because we don't have as much of that.
we definitely know, even on the ground, we're gonna learn a lot just for putting in our payloads.
Yeah.
Having avionics loaded in, all of the different avionics parts. I'm sure there's gonna be a couple issues that come up where there's a connection that needs to be made, and it's not the easiest connection to be made just because of orientation. And so we're definitely gonna take that, learn that all in prototype 1, and then incorporate that knowledge in prototype 2.
Speaking of which, pretty sure the course doesn't change per mission. So mission 3 with the banner, that's also going to have you do that 360 loop with the banner. So yeah, whenever you guys do your test flights, make sure that you can actually do a turn and do a 360 with the banner on it. One really big thing to consider is Kansas, as we were able to experience, and it seems to be the case every single year, is it is ridiculously gusty. So if you ever get a chance to test the banner and the plane and the tow line, making sure that the banner can actually stay upright, especially in really gusty conditions. Because Kansas is gusty bad. Like, don't fly for portions of the day just because nobody can take off. So making sure that the banner can actually be towed in the air with those wind gusts. Don't have too many answers or anything about that. Just gonna have to test it out somehow and hope for the best, as many teams will be.
I will say I do have, I have a lot of questions for Aero, like the Aero sub team, and I will talk to you about them later. I don't want to take up all of y'all's time. One question I have is, why was the choice for 15-inch chord length made? It seems like with the limited wingspan, you'd want to maximize that. Why not push it to 18? Was it a manufacturing constraint?
It was mainly a manufacturing constraint. I believe the laser cutter we were considering at the time only could put up to 16.
Okay, that's a good answer. That's a good enough answer. Yeah. Another thing, and then I'll pass it over to Andrew. Why DIY landing gear? Why not just buy it off the shelves?
So we originally were going to do commercial off-the-shelf landing gear. We thought, yes, why would we make our own? We could just, find some. It is actually surprisingly hard to find landing gear with the ground clearance required, because we have to have at least 8 inches of ground clearance for the banner to in our phone. The landing gear that you can buy for RC aircraft and those things for that size are meant to support aircraft that per scale don't have the same weight. The RC aircraft that the commercially purchasable landing gear minute are made mainly of foam and are hollow, like almost entirely hollow. So it's very difficult to find landing gear. We could find one example online, not just on Amazon, but on a variety of different places, RC hobby stores, and it was of dubious quantity. So it became almost cheaper, easier, and faster to just have it designed by our team and get it made.
Okay, very good reasoning. Very good reasoning.
Question also pertaining to your landing gear. Since you're doing it, since you're making your own landing, you're not buying one off the shelf. And in previous competition years, the landing gear has sheared off both, I believe, Flying Cougar and the Carbon Cougar. How much testing is going into the landing gear itself? What's being put into that?
So since we have not made our actual design yet for our landing gear, we just know that we're going to be making it. We haven't quite gotten to that point yet, but we will definitely be doing testing, because again, we don't want to smack the ground, because if our banner system touches the ground, it's mission fail. So we really do plan on doing really heavy drop tests.
Yeah, that's also something we'll learn from prototype one is when we come in for a landing, we'll learn very quickly if it'll survive or not. As we've learned in previous flight tests, when we landed, it's sheared off before.
Drop tests is
Yeah.
is what you're gonna have to do. You're gonna have to build it, put it on the plane at speed, whether you're actually just flying the plane and you're coming in and you're accidentally doing heavy landings, or you're gonna purposefully really try to just ram it in to test out what that landing gear can handle, make sure that the fuselage doesn't crack and whatever from doing that, because also, this is just an overall thing. The landing gear, way too far back. Also, where's the CG projected to be? Because from the way that it looks, where the avionics is placed, the motor is placed, how thick of a fuselage it is, it seems like the CG is also going to be pretty far back. And with all the payloads, the passengers, and the cargo, it seems like the CG will be pretty far back.
So XFLR 5 does provide a CG. That is more of like an analytical database, and we probably have to verify it with real world testing. But I believe we can simulate a more accurate CG on XFLR 5 if we take into account the different point notes.
In XFLR 5 and all these analysis tools, you can set where the CG is. And you can use that where you actually set the CG for the best performance, and you use that as a goal to work towards. A lot of the CG you can actually just do by doing a quick like hand calculation in algebra. If you know how much the ducts weigh, you know how much the pucks weigh, you know how much the motor weighs, the battery, you'll get an idea of how much the landing gear is going to weigh. And just an overall in CAD, you can set a density for some materials. And if you get one close to the actual density of the material you're working with, you can actually get a CG from the wood structure as well. And you can get an idea for everything. So it'll just be very basic math. You can total everything up and find out where that CG is going to end up being from a specified data point. You specify that. Because with this, it looks like the landing gear is really far back. You're going to struggle to take off. And also, it just having all the payload and banner be behind the wing, and then the battery be below the wing. The only thing in front of the wing bringing the CG forward is the motor.
So the plan is to have the battery directly where, at least where we currently believe the CG should be, and as well as our cargo right there. That's why we're doing a double-decker system.
Yeah.
We haven't had a chance to do the CG calculations yet, but we're still trying to figure out exactly where everything's going to be placed first, and then we'll do calculations, see where it's at, and adjust as needed.
Yeah, it definitely do that.
Yeah.
You need to know where the CG is, of course, for the design report. And when you get there, you guys have to put the stickers, or I don't even remember if we put stickers or Sharpie last time, but I think we did Sharpie. But, so you will definitely find out, but it does look like the wing is probably going to have to come back pretty far, just because having stuff right below the wing that's heavy, that still makes it neutral. But the especially with the carbon, was it the carbon cougar? No, the flying cougar. We completely underestimated how much tail section brings the CG back. And since it's a tail section that's mostly body instead of a boom arm, you're getting a lot of weight, where the majority of the actual plane, the airframe weight is behind the wing. And so it seems like a lot of the CG is actually going to be pretty far behind the wing. So already anticipating, it looks like the CG is probably going to be right in the middle, which is about 15 inches away from the center of diagram, or 10 inches away.
I would also like to note that this diagram is not representative of the
Yeah.
placement of landing gear. It's just the representative of it.
I figured as much, but just as this being the visual representation, if anybody's looking at this as a visual representation, having it in your mind, knowing that that wing is probably going to go much farther back, and overall the plane will probably end up being a bit longer. And then, yeah, that landing gear will go. Since you'll probably want it closer to the CG, just as a note. When it's far back, Obviously, if you have the plane sitting on the ground and it's already tilting up, then it makes it easier for takeoff. But if it's at a pretty neutral position at a low angle of attack while on the ground, having the CG far away from the landing gear means that the pivot point's really far away. And sometimes it just makes it genuinely impossible to take off. Especially if it's bouncing and it's kind of pointing down to the ground, or there's wind gusts and it's really just pushing it down. You might find that it doesn't take off. So just keeping it in mind for when you start building this and start getting the final designs going in, you're going to run into that. So it's just really important because we had to redesign the flying cougar. Yes, so we chopped it up and moved it like 7 inches back or something. I don't even know how far. It was basically went from the front of the fuselage to the very farther than the back of the fuselage. We had to bring it as far back as possible to get the CG correct.
I remember we basically moved the whole wing back by the wings dimension.
And even farther.
Even farther. Definitely take that into account. We just haven't done it yet simply because we didn't know exactly where all of our masses would be. And also we were trying to get kind of what the weight of the wing is going to be based off what the design would be and all of those smaller details. So as we develop the CAD,
And then, yeah, the aerodynamic analysis, use that CG as the goal point. So you'll set a location, you'll do your analysis for the best ability. You will play around with the CG as opposed to the other way around. Well, it might tell you where the CG should be and you can go off of that.
Yeah, that's.
So what we did, we actually assumed the masses of the cargo, the avionics and the motor. And then we did place them in strategic places. However, that's not fully accurate because we still have a lot of other masses that are missing, like the banner system and, you know, the plane itself. So we are definitely going to do more analysis on that, more tests. We're going to do we're probably testing as well on the prototype. But we are definitely still looking into the proper placement of everything to ensure center of gravity.
And
So the current CG value that we have is based off of those assumed point masses.
Okay. Yeah. So yeah, you'll just find it. You might even be able to do a massless plane and start from there. And then I forget which ones, but there's ways of finding out where based off of certain parameters, certain ratios for the airfoil or just the aerodynamic selection, the wing selection, the empennage selection, you just have those basics, the basic dimensions, and then you can plug in some numbers. I'll have to see if I can't dig it up. I'm not sure exactly. It was 3 years ago for me at this point, but you'll be able to find out how far away the CG should be from the tip of the wing or the leading edge of the wing. You'll get some data like that. So there's lots of tools for it, and you can set the CGs where it should be for the best performance. And then your goal will be to make sure that when you build the plane, you get the CG at that point. Those heavy planes don't fly.
For avionics, very good. Everything was explained very well. The only thing I will say is I didn't see a trade study. I'm absolutely certain that y'all did a trade study. And that's okay. I just would like to have seen it because y'all put a lot of work into that. So show it off. Yeah. And for the this isn't a serious question. For the 8-channel transceiver system, did y'all buy that? What? Well, doesn't have to
yes,
transceiver system.
Yes.
Okay. Did y'all buy that recently? Because I remember that being
This was a donation from basically.
Okay, but that's a recent addition to the team.
Yeah, about like a year.
Okay, because I remember us always talking about getting that 8-channel. Good to see y'all finally did.
With telemetry?
Yeah. So
Hell yeah.
good playing around.
Been flying blind the whole time until now.
I don't know if I didn't see this in the presentation or if I missed it. I didn't really see how there was integration, how you held like the ducks and the pucks together. I might have missed it through the presentation.
Low friction fits.
Was that in there?
Speaking of which, I remember this being a thing on the methods. Initially, it was a friction fit. Turns out the rules is no friction fit. Overall, also like the double decker thingy and however your hatches are, just make sure that the rules don't say you can't do that, because I know for the Carbon Cougar, there was like really specific rules on what the hatches had to be and everything. And so just make sure throughout the process, every time you guys design something, you make sure that it doesn't break the rules. FAQs, they put them out, participate in them, very important. Make sure that they don't specify that a specific design is not allowed, and make sure that you're not doing that specific design. Because very often they end up doing that. And just make sure you don't violate the rules, otherwise you gotta remake parts of the plane at competition.
Yeah. We are in the process right now of rereading the rules and then going to basically go at this from a rules perspective.
Absolutely.
But yeah, especially since they finalized them now. There could be any more changes.
But yeah, so distracted from the initial question about the mount.
How is it mounted?
So it's gonna be mounted, there's gonna be Velcro on the bottom of the plate on the passenger side, and then those things go over the hubs, there's gonna have Velcro on the bottom corner, so go in, stick them, and place them in the yeah, we're trapping each stuff.
Practice that.
Check.
Yes. One thing about that I would take into consideration. Okay, so cargo right underneath the wing. How are you gaining access to that?
There's gonna be a hatch
Far
on the side.
On the side?
Yeah, we're just.
Okay. Yeah, as long as it's that way.
It's not shown right now.
Yeah. Okay.
As per the rules, we are allowed to have a speed loader for cargo, not for the passengers. Passengers have to be individually loaded, but cargo can just be speed.
Yeah, just make sure you design, this is something you can like even do some 3D prints or basic cardboard cutouts that block out certain sections. Practice that, just especially with having to reach in areas. Sometimes Velcro kind of sucks in the sense that if you have to reach in somewhere and you want to rip it out, Velcro is kind of hard to with it unvelcro. How you just it's hard to take off when you're pulling out. So yeah, just that's something you guys can test soon. As is. So just make a cheap cardboard prototype with some Velcro and some small cheap 3D prints, and not even have to do ducks. You can just find some trash or something and just see how it actually fits. You can do that like this month as well, just to make sure everything works before a full prototype. Because it would suck to find out that you built a prototype and then it turns out you got to redo a lot of stuff that you would probably much rather have done previously.
I have some questions about the banner system. Firstly, who's the advisor for the capstone team? Okay, very good. She also teaches the class, right?
Yep.
Okay. And
So you guys have to do presentations to her. It's brutal.
Also, that I have a final presentation with her on Monday.
Nice. She's good.
but for the banner deployments mechanism, what other mechanisms were considered? Like, what was the ideation process behind this that made y'all decide on that? Did you like consider several alternatives, or did you just?
Deployments?
Yeah, it's like the release system.
Yeah, so we did look at different designs. We thought of three initial designs. One was like those hooks. Another was like an unroller where we could wrap the banner around the bar and then fix it. But when we really like thought of it, it didn't really work out with the space we had. And it all has a bit.
So just as you test it and build it and everything, making sure that the banner is really secured.
Yeah. We're thinking it'll kind of clamp down on those straps, which will clamp on those
Make sure that while it's with wind gusts, while it's flying, while it's on the ground, just making sure that it doesn't slide out. Even if it's being clamped down with how thin it is, it might start to slide out and unfurl. You might find that while it's like the air catches inside of it while it's wrapped up and it starts to just unfurl it out of the loop. So just make sure that there's some, either you do something to mitigate that, or if you test it,
Yeah,
and it turns out it's not a problem, then that's not a problem.
They're planning to do a whole like test template launch, and then we're gonna have it under there, put in some max speeds.
Yeah. And then the car test as well, just
And the cartons.
send the car. No, sorry.
Forward.
Oh, definitely practice like with making laser cut parts. It gets complicated fast. And like,
And dealing with kerf, manufacturing the parts so that they actually fit together
Yeah.
appropriately. Otherwise, you're gonna have a lot of sanding, which isn't bad, but it's not great.
takes time. But yeah, just sometimes there are some parts that were made and it was kind of like, okay, we put this together and then we're planning to put this other part together and it's just like, oh, that like physically is impossible. And so just start making laser cut parts.
It was my first time laser cutting, by the way, so don't,
Yeah, no, it's-
don't judge my work I was doing sophomore year.
Well, it's also my first time designing laser cut parts. So just the jigsaw stuff, it can get really complicated with like, oh, how is that getting together? So just start making stuff so you get an idea of how it works. Ways that you can skeletonize things without screwing up the parts. You just get experience with it. That's all. Definitely don't have the prototype also be like the first time because it's just you're gonna run into problems.
Less a comment, more a concern that I had basically every year that I was a part of Aero. I find it very worrying that y'all's first flight tests are in like March or April, according to the Gantt charts.
Right, like flight test will happen with the prototype. The prototype will also.
Yeah.
It's gonna be in February, January after that.
Wait, I remember, yeah, that was
Yeah.
concerning.
Prototype 2 will be later.
Because we've dealt with those dates and timelines before, and it's wrong.
The manufacturing of the prototype one, that's the one. Right? And when it's done, we'll start testing. After testing, we can have a CDR and this feedback and I start refining us.
Try to get, oh, go ahead.
I have a question that's relevant to this. Are you gonna flight test the first prototype to failure?
Yes, that's the plan.
And then on your work conditions, do you want to test like the final prototype, right, along that line? Are you concerned about the potential of damage that could prevent that version from flying at competition? And how do you account for that in the project timeline?
So the current plan is to test prototype 1 to failure so we can understand where the failure points are. That way we're more confident in our prototype 2 where we basically minimize that situation from happening. We haven't accounted for it yet in the Gantt chart, but hopefully once we finish manufacturing prototype 2, we can start to take some time and maybe manufacture some extra parts for that final test plane so that if there is a failure, we are able to at least fix it. And so that is currently what the plan is.
Yeah, we're considering having multiple replacement parts for the competition plane in case of things going wrong during testing.
Yeah, basically just along the same lines as they were saying, try to do those final test flights early enough to where if something happens, you still have enough time to actually go to competition with it.
Be ready to remake the plane.
Yeah,
Yes.
just in case.
So-
Maybe MV.
Several times.
Yeah, change the number MV-1. Oh, you show up to competition with MV.
MV0.
So yeah,
Winter break.
For the testing, like the wing loading tests and even the CG tests, you can do that without having a full prototype. Like you don't need an avionics system in them at all. And especially if y'all are planning to fly the plane until it fails, right? Is that what I'm hearing?
Failure.
Okay, okay. Again, and you don't need a whole prototype to do that. I think it would be faster and will save a lot of construction time to just like put a spar or maybe just make the wing with the spar and then test that.
Yeah, the idea is hopefully with parts like the wings, any of the empennage, we can make multiple of. So if those fail, we can fix that easily just by replacing them. things like.
You break a carbon spar.
Yeah.
Just make sure you get it on footage
Yes, test it, footage, document, weights.
and at alumni.
Yeah.
Um. Yeah, winter break. Sometimes it's a problem, sometimes it's not. If you're trying to do something, get halfway through it, and then winter break happens. Sometimes people aren't available, and so then you get into January where people are coming back, semester starting, and so things don't actually happen until February. And then you guys are going to be busy with the design report during February, so you're not going to be able to test that as well. So it very easily could be that the first prototype, if it's not finished pretty soon, will get backed up, and suddenly your design report is in and you've never had a prototype. So ASAP. And what else? Oh, so for the case of like a catastrophic failure, so you fly the plane, you do all your tests, try not to crash the plane, and then you want to really test it to see what it takes to crash and break it. Do you guys have more than one motor? Because if it nosedives, bends a shaft, completely shatters the motor, breaks a battery, you're out a receiver, ESC potentially out a battery. The potential is you lose your entire avionics system from that.
And I had longer lead times too.
Adam?
That has longer lead times.
Yes, that has longer lead time. Right now we have the one motor. If the budget allows, the plan is to buy a second motor, so that is not a failure point. A backup would be getting a cheaper but lower thrust motor or lower quality motor.
Around.
Yeah, we do have quite a few motors. The only thing is, at this time, I'm not sure if they can provide the thrust capabilities.
They might not, if you can still get it up though.
Yeah, I think we tried.
Some
We
of
have
them
a-
definitely don't work.
We have a couple of larger ones that I think should work. It's definitely a bit of work right now, but again, if budget allows, that is the plan to purchase.
Okay. Yeah,
For now-
definitely plan on that. Because, yeah, I mean, if you have a catastrophic.
Yes, as happened with Carbon Cougar.
Yeah. It nosedives, breaks a motor, and you don't have another one, that's pretty rough, especially if it happens soon before competition. So if possible, definitely motor. I think you guys have multiple batteries.
Yes, we have multiple batteries. We'll probably hopefully we can buy some extra batteries too. So we have even more backups.
Haven't seen ESCs fail too often, just in case. I try to be ready. Usually I really haven't seen those fail, even with crashes. Yeah, so
Yeah.
that should be fine. That small battery, probably be able to toss it around. Should be fine. It's tiny, so, yeah. Make sure to stress test those servos. Having cheaper servos, sometimes they don't work, sometimes they're not consistent. Sometimes they can break. Just stress test those servos. They are cheap, which is good, but also sometimes people struggle with cheap servos. And sometimes they just start failing. They have a plane that works, go to competition, we talk to some teams, their servos just broke, no longer working, and they can't fly it. So just make sure the servos are good, consistent, strong enough, don't stall, and break under load. For the wing, there's that main spar, and then there's the carbon rod. Just keeping in mind that carbon rod is probably only going to be good for keeping the spar or the ribs in place, but it's not going to be good at preventing the wing from twisting. And 4 feet is still sufficient to expand, probably to where the wing might start twisting. So just be mindful that you might have to have a secondary, like rectangular spar that goes across if needed.
That's the purpose of a 1/4 inch. It's carbon fiber. It's an anti-torque bar.
Okay. And there's a second bar behind the main bar.
You still get portion because they bend a bit.
As in, is that like just having a really thick main spar? Or is there a second?
No, there's the main spar. It's,
Yeah.
I mentioned there is the main spar, and then behind that, about an inch from the trail, about 2 inches of trailing edge. Sorry, about half of the trailing edge.
Okay,
Yeah, that black is a 4-inch carbon fiber ring.
okay.
So that is specifically there to help counteract.
Is it hollow?
No, it's solid. It's solid carbon fiber.
So, yeah, that's what I meant. So having that one there, the way that it's placed in the wing, probably won't do too much to prevent torsion. It might. Test it out, make sure it's good. You know, spar placement, you'll figure that out wherever the center of pressure is. But very often the balsa, or the whatever wood, if it's the balsa wood or composite wood, those vertical strips that go along the full length of the wing are pretty good at creating a box structure. That's also good to keep twist away. So it doesn't need to be carbon to prevent twist. It just needs to have a good box structure to prevent twist. And keep in mind that the tips of those airfoils, when you do the monocot, make sure there's something keeping those in place, because the monocot will really shrink and try to squeeze. That happens every single time you make wings. That the top and bottom of the ribs, wherever it's just a really long span, those will start bending because the vinyl is pulling on it. So just make sure that you have stuff to keep the structure of the wing from bending and bowing and twisting. Because it's going to start bowing, it's going to start twisting when you start to apply a heat gun to it. We've experienced that with previous planes. So you'll find that it happens. Yeah.
So a lot of what we're talking about, testing, is very budget reliant. Did I remember correctly that earlier in your slides, you said that you're already in a budget deficit and you might not have the funds to do the full things? And is the testing that we're talking about right now included in the budget that you presented?
Well, part of the budget though, our solar function fund only goes to the components. It only needs construction. Logistical sides, it's still kind of high right now. You're estimating some people, 4 cars, and that's $3,600. And for that, it's still budget. And also for testing, yes, we may use budget. Obviously, for type 1, if one necessarily use the materials last year, have to buy propeller, also landing gear. That will also have to budget. So we're still budget of $4,263.
Is prototype 1 included in this?
Yes, this includes two aircraft, prototype 1 and 5.
And prototype 1 is already set to be, we've expected it to get destroyed, either for testing or through a test flight. That is the plan right now.
And if you're able to salvage a lot more, that'd be awesome. Yeah.
How involved have alumni been leading up to your progress to PDR? And how involved do you want them to be leading up to launch, and in what way?
So yesterday, especially Tommy, he had a CAD workshop for Tommy, CAD. Yes, our use along here. So we're very thankful for that. But we want to be more with alumni, and we want their feedback and support for work this year. Also, as you know, Aero is relatively cheap. We have history for about 5 years, and we don't have much coming up. So we are really for alumni support, not just Aero alumni support, but Inspire alumni support as well.
Especially because big alumni did not compete, so we also have little competition experience. So we're extremely limited on the kind of feedback we give, because there's a certain point where you guys end up either knowing more than us or somebody else knows more than us, and we don't know. So we'll avoid the experience there.
Just kind of building on a previously asked question. So I know you said you had your budget accounts for 2 aircraft, but you said the first prototype would be tested to failure. So do you expect to lose all your like components that you put into it, or?
So in terms of components, we expect to lose only structural components. Obviously, not much we don't be avionics components, because I believe that's more for final aircraft. But in terms of the fastball and also the structural components, yes.
And in the past, most of the avionics parts should be relatively safe from any catastrophic failures if they're inside the main area of the fuselage. We have backups for like batteries, which if the battery probably the heaviest thing in a catastrophic failure that would probably get thrown out, take the most damage. Most of the other parts are lighter or can easily be reattained if needed. The only big worry would be if we had a nosedive and we lost the motor. However, the plan for with prototype 1, if we were to lose the motor, we would have enough time for another one. But it would be a bit of scrambling of budgets and rearranging our budget to do that.
Yeah, our current budget does not reflect losing some of the avionics components. If we were to lose some of the avionics components, our expected price goes way up.
Specifically just with the motor.
The monocoque price seems pretty high. Is that how much it's always been? I don't know if I'm just underestimating how much we spent on monocoque.
Yeah, we
previously,
definitely never spent that much,
but it just seemed like the monocoque budget was pretty high, $240.
which isn't bad, but definitely higher
Yeah.
than.
It's based off of 2 plane and extra in case we need it.
If you end up not needing it, potential area where you can pull budget for a new motor. Yeah, budget is always a big issue when you don't have it, so.
I do want to mention that for that monocoque, that is got, it's double the price, assuming that the monocoque that we use for the first plane is produced exactly the second plane. And then also that is, I believe, the most expensive listing I can find is the one we used. So it is very much possible to shop around and find deals, but we don't want to have an instance where we can't find that deal that was there originally, and then we don't have money out for and to, have some reliability and can we get our, because that's something we don't have.
Yeah, and that's also part of our like contingency budget. We can reach that goal.
Yeah.
In case things go wrong, that's part of why we have that plus 15%.
No, just, I guess, what's the lead time on your motors? Because when you say lead time, I'm thinking 6 months.
Our bar is very.
Oh, yeah, I know, it's not rocket components. I can tell you that now.
Yeah.
I will, well, no, I think we try our best to not try to import it from China. That was a very big criteria for picking a motor. We can't source it within the US. I think it's something that you know how to for.
Yeah, in the past, at worst, we've had is like month lead times. So the biggest issue we've had in the past is where there's the specific motor we're looking for is out of stock. But we can also again use a similar motor that's not as quality as the one we want as a backup.
Okay. I had a question about the lead time. Like, have you guys looked into how much it would be and like the lead time for your landing gear? Like what company you'd be purchasing this from? So. It's like you're making it yourself and you're gonna get it manufactured somewhere that actually I'd assume a pretty good amount of time.
So we have not gone fully again, like I was saying earlier, it's not fully pushed yet. However, we do plan on using something either possibly through the university whose actual machine shop, something of that sort, or just outsourcing.
Have you looked at the lead times at the university?
I have not, no.
They're very long.
Yes.
Yeah.
They're very long.
Capstone. Well, you might get priority as a capstone team. But even as a capstone team, you might be wanting, like for capstone 2, we start building stuff. So we'll have something and it'll be a month. So it's like it's already March by the time the capstone team is even able to get stuff. So even for capstone, it's long.
Also, just looking at that price, that might be if you have, I don't know, maybe if you have two of them and you manage to do the manufacturing through the University of Houston. But that does not look like a landing gear or something that might fail during testing. That does not look like if you were to do outsource machining. I don't know a ton about it, but I think that 75 seems pretty low for good metal and then being machined with a decent lead time.
So we plan, not plan, but are in talks of planning of using aluminum, which is not entirely expensive, and also mentioned that, again, we haven't gone fully into the details, so it may become slightly more expensive. But also it's not a huge, in terms of its complexity, our plan complexity, it's not crazy and it's
Only the front being the,
we have quite a few different options.
okay, because sometimes a lot of the front landing gear, there's portions of it where it's so simple that you can hand cut.
Oh,
Sometimes,
so I didn't,
preferably not. but-
I didn't know that you were having a already provided back landing gear. I thought you were going to manufacture those.
No.
Yeah, the back one's a little harder to manufacture, for sure.
I have to add to that. Like machine, manufacturing those, and sometimes he has the materials ready. So depending on that, over and like.
I have two last questions. One of them should be very easy, and the other one is going to be the most difficult question you may have to answer. The first one is transportation of the aircraft. When you're doing what's the word? One where you don't have a tail boom, an integrated fuselage. Like, are you planning for this to fit in like someone's trunk and like have the wings pull out like how we did with the Flying Cougar?
Yeah, because we barely fit in that car.
Yeah.
And yeah.
Eventually, the plan is to use a truck. One of our members has.
Yeah, so I have a truck with a bumper bed.
Okay, cool.
And you're cool with driving it all the way to Wichita?
Yeah.
I want to try that.
Who's paying for gas? Okay, it's in the budget.
Yeah, and our design is to take out the wings and make it full of.
Okay.
You
Okay.
need to.
And the second question, and you can also jump in if you want to do this. I see a lot of y'all are seniors, about to be seniors, hopefully graduating. How in the spring semester do you plan to attract and engage freshmen and sophomores into the club in a way that kind of keep the ball rolling in terms of the quality of the team that, is happening right now? Because it took like 5 years from us to recover from COVID. And, like a lot of y'all know me since y'all were freshmen, and I probably was y'all's introduction to the team. And I'm glad to see that y'all have also, indoctrinated new freshmen into the team. Inducted, yeah, that's probably less culty. But yeah, what's the plan for attracting and engaging new people into the team and also teaching them while you are doing a competition? Because I know it's not easy.
So I went out on a limb kind of and started my own YouTube channel. It's called the Aerodynamics channel. There are 2 videos posted. I'll get y'all more details on it probably later. It's mainly, for now, it really just covers XFLR analyses, but in the future, we could also cover CAD really, and I'm sure that there's a Space City Aeronautics YouTube channel and a general AIAA channel, which we could also implement to like keep members attracted.
Good to document everything as
Yeah.
well. Very good resource for you to look back on
Yeah.
for what you did, but also,
Yeah, I think for recruiting, at least the hope and plan right now is since we got into competition and essentially we're getting into what I think is the fun part of Aero, a lot of freshmen and sophomores can be brought in to be part of that process. And I think a lot of the problems we have with recruiting is that they join and then we're like, okay, we need to do this research, we need to do this calculation, we need to do trade studies, and a lot of members don't want to do that. So having that hook of we're going to build this plane, we're gonna go fly it, and then we're gonna go to competition and fly the competition is definitely gonna draw in and more members in my opinion. Also, being able to hopefully get the budget to increase that amount of people that can go to competition means we can have more we can tell members we can bring you to competition. And you can, attend with us at no extra cost, but to you at least, would definitely help, I think, member retention. Right?
Another thing is having the prototype as well, being done pretty early on in the whole timeline. It's definitely going to be a big attraction as we have something to deliver. We have a prototype that we hope would be a good incentive, especially because during events we could even, with proper permissions, have it fly around.
Okay.
And for knowledge, I mean, we kind of have our leads we're just kind of like separated by a year apart each graduation. So even though I'd be leaving soon, Amir would be leaving like a year later, and then Francesco 2 years later. So at least
Definitely good to stagger that. Because
yeah,
there's times where everybody that's in charge of everything all graduates at the same time.
yeah. So
And it's a big dump of experience and knowledge that just
yeah,
You get one person there that knows what they're doing, and like, they have to teach everyone else.
yeah. So the plan is at least one of us will be there every single year to guide the team in the correct direction. And also for our leads, like half of our leads are still around sophomores, so we still have them, and it's just teaching the new sub-team leads like how to do this. This would be part of the process.
definitely prototype before winter break then.
I do want to mention as well specifically for, as I mentioned, structure on the co-lead, I'm a sophomore, so pretty young. I was, honored to be part of the fuselage freshman under Andrew and Andrew under Tommy. It's a somewhat of a tradition, that I'm trying to change around and kind of, so, anyways, my point with all this was, actually, I'm super proud. I wanted to bring up this slide. So that duct holder, that entire passenger section was actually made by one of our newest freshmen. And so part of, at least my personal as part of structures of team leads, we are trying to involve not just members in one part of, like, not just the trade study part, not just the boring, or not boring trade study part, not just the fun CAD part, but involving them in everything. There's no, they truly get to feel involved, in my opinion, of course, not speaking for the rest of the team, but for structures at least, getting to be involved in everything, not just they get to see one part and somebody does another part, but they get to see everything. And I think that's important.
I will also say many of the trade studies that you see in the aerodynamics portion were initially drafted by the newer members, and then I would step in and verify.
Yeah, I mean, definitely have the leads finish those up. As the leads, you are the final, like step for a lot of these things.
Well, mentioned for avionics, Gabe who has been teaching me, making sure I understand. One thing I've noticed is that, yes, the boring trade study part is not the most engaging, especially for other engineers. And the hope was, and I was looking for past design reports, and there was some very experimental things for circuitry you can even do, maybe not even going on and being flight, but making a prototype. And that's something that I want to do for the future. Where, sure, we're just plugging things together, but we can experiment more. I know we talked about current sensors in the past. We talked about integration of like telemetry and that. Just
The initial setup for the propulsion system was kind of, we had no idea where that was going. And then once you figured out how they are, it's pretty similar every single year. So you get a little bit more room to get past the easier part and get into the more interesting.
And I want to keep some engagement.
Also, is anybody monitoring the teams or okay, just making sure for like waiting room, chat, everything.
Yeah, like having cameras and like having maybe a first person flight mode for the prototype, you mess around and challenge maybe.
Yeah, because we're not allowed for DBF to have a camera in it. Onboard footage for maybe like a prototype.
Lots of teams during test flights will do it. Even on the final plane for test flights, they get that. And then in competition, there's no cameras. But every other time it flies, they have a camera.
Yeah, so that's something
which, if it's not in the budget.
Oh yeah, this is not this year, but like this is something we've talked about.
If you're able to this year.
Yeah, it would be nice to have it this year, but
maybe not prototype one where we're playing a crashing.
maybe not.
Well, yeah, but it is
You would be planning to crash it, but just that you would be pushing it pretty hard, and then the expectation is it's probably going to crash. But you're definitely not going to be planning to break it. You want to push it to its limit, and you might find that the spar survives, everything survives, and that's great. Then you just keep going. The design doesn't need to change. But there's times where you might break something. So
Yeah.
you might be trying to push it as hard as it can, but there's a point where it's like, okay, we're not going to push it further because it's not going to be pushed that much farther. Then you get to save the plane. Or it turns out that you're able to fly it and its limits are aerodynamic and not structural. In one case, awesome as well. You don't lose a plane.
Yeah.
Don't break it just to break it.
Yeah,
The only one would be the wing test, which we would be intentionally breaking a empty plane.
yeah, the wing would be the one thing intentionally go until it breaks, and it's not usable. But a lot of the tests is the prototype, if it breaks during a hard landing.
For it to.
We were planning for it, but we are not gonna actively nosedive the plane into the
We're not
ground.
nosediving.
We might do a few hard landings, like you mentioned. Especially here.
Yeah, hard.
You're not actively gonna nosedive into the ground.
So, I guess to clarify, you might not want to attempt hard landings just because you might risk crashing a plane that didn't need to crash. But just that hard landings might happen. But definitely with a plane that is mostly just not having any of the important stuff, but you've loaded it with a bunch of weight and you're going to drop test it, where you're going to break a lot of wood that you might not care about breaking as much. Break the landing gear, make sure you have a backup.
Like say I think our testing philosophy is hope that it survives everything so we can use the plane, but expect it to break. I think if we get a significant factor of safety and it hasn't broken already, we would probably just stop there, just for the sake of saving our equipment.
Because ideally, you do want to do that whole thing, but because of how tight the budget is,
yeah,
probably going to be realistically a lot more like, ooh, don't break that because you just don't have the budget for it. So
Yeah, I mean, if we get to double the weight of the expected plane and it still hasn't broken, I don't see honestly much of a point going forward.
G loading, I mean, if you're pulling 8 Gs, that's 8 times the weight. 10 pounds, 80 pounds. That's
Quickly, I would like to interject. We have a couple of questions online. Are there any other questions? We asked in person before transitioning to the online question. Who's the pilot? And is there training kind of built into your plans for potential?
Yeah, so our pilot is not with us right now because he is currently in a co-op. However, Carson, he's going to be coming back next semester, and he has tested on our planes before, and we do have a plan to get him more test flight experience, at least beginning and simulator, and then hopefully testing on maybe we do have some kits from we have some old test kits that we have made a phone.
Those 2 white ones?
Huh?
Those 2 white ones?
Yes. So hopefully we can the plan is also get him that to get test flight experience, to get some days where we go down and he can fly those out.
Which isn't so, yeah, we could also train a backup pilot, which train a backup pilot in the case that Carson is not able.
Yeah, that was my question. Who's your second pilot?
Competition pilots, right?
Yeah.
To be determined, we are still ironing out that detail.
Yeah, at worst, we can coordinate with a pilot at AIAA. They do have the competition. AIAA does provide test pilots. However, the optimal choice would be to have one of our own pilot who's experienced with the plane do the test, because then they can account for things at competition that you may not have been able to fix before. It's also preferable that we have a pilot who understands the plane, so you're not learning it at competition, any of the minor issues that come up. Any questions?
Questions?
They just left, but I had a question about the capstone team is, I guess, how are they, I know Amir is here, but like, how are they integrated into SCA? Like, do they attend your regular meetings or are they just kind of do their own thing?
So, they, and most of the things. Most of the time, very, most of the time, captain, I keep them updated. I pretty much work as a engineer, but I believe me being in a team as well as Nathaniel structures for me being in a team really helps with better deployment system, the placement of it, the area required, the length of the bay, all of give that us being in the team that
Okay, just making sure that there's, communication on what's going on, because
Same
Yeah.
concern. I was very happy to see that at least one member is also like in charge of the team, so you're not anything.
Yeah, half the capstone team is half our SPL and lead, so that helps a lot. I'm happy about that.
One other just minor concern, at least for us, hope we don't really go into our test flights like hoping our ship will survive. Sorry for cursing, but so I don't know, it might be if you're planning on, destruct or pushing your prototype to the limit and possibly breaking something, I would recommend budgeting for like, the major things just to not, I mean, obviously we all hope that, nothing will go wrong, but
Yeah, again,
Because they have money.
yeah, again, the biggest, right now with the extra material we have, biggest thing we have pretty much accounted for as extra is the motor, which would be extra $100. So while it is a cost, hopefully we could rearrange, it's within such a limit where we could either rearrange some budget in certain areas to deal with that, or hopefully we would get a beyond our budget and we could increase that. There's also that 15% extra budget that we're trying to reach. So for cases like that.
The budget does account for a secondary. So when we say we hope that the first one doesn't get destroyed, it's not that we're like not ready for it to be destroyed. We're gonna test this limit. If it gets destroyed, we're already accounting for it in our budget, except for like some avionics.
Yeah, we planned and expecting for it to be destroyed. We're just hoping it would survive as a sort of backup for competition.
Just because most teams do end up crashing for one reason or another. It always just happens. But we're also really experienced.
Quick suggestion to go alongside that, and I'll stop. If you are doing destructive testing, design your plane in a way that you know what will more than likely fail in certain areas. So design intentionally weaker areas so you don't have critical systems affect. Yes, perfect.
I'm now gonna officially transition into the online questions. From Jalissa, she had a question, any risk tracking for the team designing the landing gear? Or for the team design landing gear?
Risk tracking?
Risk tracking.
Make sure they can hear you. You're right.
I don't believe we've gotten to that point. Once again, we have made up a decision that we will be making our design and outsourcing it, but we've not gotten further past that.
I have a question from Carson. How has COMSOL improved the capability of aerodynamics in analysis of the airfoil data?
What is different with console is that we use estimated flight speed as boundary conditions, and we correct for the time. With that, we were able to accurate the max surveillance numbers. And I know safety is not very accurate, it's very hard to learn from the master. But if looking at matching surveillance numbers more accurately is more than the accuracy of the overall simulation.
It gives us more data to analyze.
That actually relates to the follow-up question he had of, do you have a preference of it versus XFLR5, or has using both been the most effective?
Well, as we know, because PFP, well, right now at least, got was drag function and lift function, but your home function, you have to use
As well as the stall.
as well as, yeah, home function, all,
Stall distribution.
yeah.
To add on to all that, console helps especially two-dimensional analysis. But XFLR was really crucial for that three-dimensional analysis on when we have include the wing shape with the airflow. So it gave us, again, a lot more data. So we're more confident when working with them in test.
I have another question from Jalissa. First of all, she said that she did agree with Andre, saying agreeing with whoever is speaking right now about making cross-referencing rules and ensuring design complies. She has a question specifically for Gabriel, the systems engineer. Are you tracking design constraints or just tracking requirements?
So we're tracking both design constraints and requirements, since we have essentially our constraints are the requirements. The rules are very specific on a lot of the dimensional constraints that we have to meet, which are just we have to meet. So outside of anything of the rules, it is basically just kind of left up to the team to decide from using our best technical knowledge to determine those things. But again, we are tracking as best we can all of the rules. And again, we're planning on doing basically a whole session where we reread the rules, we're fresh in our minds, and we go as line by line as we can to see if we meet the requirements of the competition.
I have another question from Carson. At some point, the team will be balancing three things: prototype, build/test, design report, continue design kinks and uncertainties. If you're falling behind schedule, what of those three need to be sacrificed, changed, or prioritized to avoid falling down a slippery slope? Prototype, build/test, the design report, and continued design kinks and uncertainties.
Okay. So for those cases, I think we would have to really determine at the time which is most important or falling behind to catch up. I'd say off the top of my head, I wouldn't want to say that the design report would take the back end, but the design report is very dependent on both our testing and our building of our first prototype. And we technically could go in competition even with not with a suboptimal design report. So while we wouldn't want to lower our score on the design report for the sake of competition and better data, I think it would be best to prioritize building and testing. But again, we would have to kind of have a meeting and determine at that time what would be the best situation, what would be our best decision.
Again from Carson, how are team meetings organized to improve work ethic / time management while maintaining a fun environment and keeping motivation on the project?
Okay. So as far as meetings go, we tend to have a quick, general consensus of explaining what's going on as a general team, make sure everyone's informed of what's going. And then the sub teams all kind of split into their own groups to work on all of their different parts of their project that where they're at currently. And while that is going on, us three leads are constantly going to lead each team to ensure that they are what work they are doing, what they need to prioritize and discuss with the teams. Sub team leads tend to we'd like to keep the members engaged as much as possible. So it's very much try to get the members to do, be involved and get the work done with the lead kind of guiding them and helping them as needed. And then us three leads basically coming in and answering any questions that the leads may have, that the SPLs may have, and making sure that there's integration of thought process and everything.
In addition, with the meetings, compared to previous years where each sub team had their own individual meetings, we have a file of more collaborative meetings. We have our primary general meeting where all teams are in the same room. And currently, aerodynamics and structures have weekly meetings where they're both working together on the
plan. From Carson again, other than a high proposal score and funding, what is another high motivating factor that the team will maintain going into the spring?
Flying a competition, I'd say.
major correct them, fly off. Even though it may, it may crash, we'll do our best to make sure that does not happen. But just going there is a major.
The return competition and every mission is, I would say, are kind of the carrot in our shooting. Our main motivation, we want to get to competition, we want to attempt every mission, we want to get a score. Like that would be basically historical in terms of this thing.
It's been a mindset that we have maintained throughout the entire year, is that we are gonna make a plan, we're just gonna go to do all the missions. It's the beginning. Like no matter what the results were on proposal, all the stuff, the plane was gonna be built, and it's been a mindset we've been keeping of having a competition ready plane. Well, obviously one going competition.
Now that we have our proposal score back, we know we're going. That is very much our motivation, is to get the competition. The only question is how we get there.
Logistics.
Well, even how we get there in terms of current design. Got a long road ahead of us. Yeah, but also logistics.
Great, well, that concludes the online questions. There is a couple of comments. I'll just read them out. Carson said, this is Carson, by the way, he came on an alias. I said, I know these are some deep questions. Thank you for answering. Fantastic job with the proposal. Looking forward to seeing everybody in spring. As well, another person going by SG said a fantastic presentation. Wishing you all the best to each and everybody in the team as you trust your hard work, resilience, and preparation, showing your true winner spirit. They are excited to see you all in the upcoming spring competition. And as well from Karthik, from the UT Arlington DBF team. Amazing presentation. Congrats, and see everybody at COP. Officially concludes. Oh, and then Jalissa said she has to drop a little bit early, but thank you so much. And overall, it was a great PDR.
You guys were great on time, by the way.
This officially concludes PDR. We can go to informal questioning. We also have a bit of a celebration to be had for Aero getting into, not only getting into competition, but placing the 17th in the world.
First in Texas.
First in Texas.
Being on it.
It's amazing.
Best in Texas. I kept trying to spin my words on my resume to say that, but I never could. You guys get to. So.
All right. Well, I'm gonna probably move the cake to a more convenient place.
Yep.
I'm gonna start serving it, but thank you so much, everybody, for attending. Thank you so much, Aero, for this amazing PDR. We're excited to see where you guys go, and we're all excited to see you guys at CDR next year.
We have any